Thank you. All right. So now we are going to write a code. So we go to colabs.research.google.com and we create a new notebook. And I'm going to call this Perceptron from scratch. So we are not going to use any library apart from NumPy for vectorized computation. We are going to do everything on our own. And this is Hello AI. Before we start coding, any question? Okay. So then I begin with importing some things. I will import some things and I will show you how to use them. So I will say this and this is something I've already imported, so implemented. So to make it quick, I will just be re-implementing it. But what I've done is here to guide me, then to make everything fast, and I will also be able to explain as I code along. So then I also have from sklearn.model selection. Import train test split. You'll see why we need to do train test splitting. And then I'll import NumPy as NP. And then I'll also import matplotlib.pyplot as PLT. Then I will say matplotlib inline so that my graphs can show in the browser without me having to call plt.show. All these things, if you don't understand, I have videos on my channel that is teaching them into details. We don't have too much time for me to explain everything. What is wrong? From sklearn.datasets, not datasets, I think so. So you see, when you make an error, it shows you. Okay, now this import here from sklearn.datasets, import load iris. The sklearn library, because it's a machine learning library, comes with some data sets already prepared for you, because sometimes you want to test an algorithm and you don't readily have a data set at hand. But the beauty about these machine learning algorithms is that they are data agnostic. So once you implement it with one of the data sets that comes with the library, you are free to later change just the data set part and keep every part of your code the same. So you can use a perceptron. Your aim is you are building a perceptron to do voice recognition, to distinguish between two voices. Fine, start with any data set that comes with scikit-learn. Train it, make sure it is doing what a perceptron has to do. When you finish, gather your audio, convert it into NumPy arrays, pass it to it, and deal is done, because the algorithms do not depend on the data, okay? So this load iris gives us some data set about flowers, and we'll see. So to actually load the data set, I'm going to load it and store it into a variable called iris, okay? So now we have the iris data set. In scikit-learn, when you load a data set, it gives you what is known as a data bundle. I think we can check the type of iris, and we can see that it gives us what is known as a bunch, a bundle of data. So in this bundle or bunch are the features and the targets or the classes also, okay? So let's do some inspection about the data set. I can say iris dot feature names. I just want to know what are the features in the data set. So it tells you that the features are sepal length measured in centimeters, sepal width measured in centimeters, petal length in centimeters, and petal width also in centimeters, okay? Now, one thing that I forgot to mention in our perceptron 10, which is very important for me to mention, is, let me go for it. When the perceptron finishes its calculation, it applies what is known as an activation. You see, I told you that the neuron activate or does not activate, and it depends on some rule. So in AI or deep learning, we have what is known as activation function. We have ReLU, TeLU, ELU, sigmoid, plenty of them. Today, we are not using any of them. It's a very simple, if is greater than this, then return 0 or 1, but it's also an activation function. All right, so we have seen the features. Let's see the targets too. So I told you that the features are, this data set is actually data set that biologists have gone to the field to measure the sepal length and the petal length of some flowers, okay? So if you take a flower, let's say sepal length, if you take a flower, I'm looking for a diagram to explain, maybe this will help. So this part of it is called the petal, this part of it is called the sepal. So in the data set that we are working with, somebody have measured the length of the sepal and the length of the petal, and they have seen that the type of flower depends on this petal length, sepal width, petal width. So we are training a model to be able to tell us which type of flower amongst these three categories that we have. But because there's a perceptron, we use only two, because perceptron can work with just two classes. Okay. All right. So let's see what we have for the target name. So I'll say print, and then I'll say iris dot target names. So these target names are the names that are assigned to the actual flowers. So if you take one row of the data set, the target will be either Setosa, versicolor, or virginica. These are three different types of flowers that belong to the same family. But depending on the sepal length, sepal width, petal length, petal width, it could be classified as a Setosa, a versicolor, or virginica. Okay. So this is just, we are trying to understand the data set. I told you yesterday and days before that as a practitioner, most of your time will be spent on data than the actual algorithms and stuff, depending on the libraries that you are using. Okay, so now let's get the data itself. I said we usually call our data as X. So if you say iris.data, then now we can get the data itself. It's a NumPy array. We will inspect it to see what it is. Eric, can you guys hear me?
Yeah.
Okay, I think.
Yeah, loud and clear.
Okay, thank you. So then I'm loading my targets also into Y. Then now let's do some inspection about them. So I'm going to print x.shape. I told you it's a NumPy array, y.shape. So it is telling me that my X is made up of 150 rows with 4 columns, and my Y is made up of 150 rows. We have to make it 1 column. Why? Why is it so? See, your features are what? Sepal length, sepal width, petal length, petal width. So you have 4 columns. That is why you have the 4 here. And the data set contains 150 rows for you. And that means for every row in X, there is a corresponding row in Y that assigns whether Setosa, versicolor, or virginica to it, okay? But because this is a data set we are using for machine learning, our model cannot work with Setosa, versicolor, virginica. So we have to categorize it in numbers. So Setosa becomes 0, versicolor becomes 1, virginica becomes what? 2, okay? So there is a way we can see how many classes there are in our output. In NumPy, when you say, let me actually show you this. If you do np.unique and then you pass in your Y, you see, even though Y is made up of 150 rows, the unique method will tell you only the unique things in it. So it's telling you Y is made up of 150 rows, but it's either 0, 1, or 2. Do you understand what's going on? Do you guys understand what's going on?
Yeah, maybe.
Okay, all right. So now we are only interested in working with just maybe sepal length and petal length. I'm doing this not because the perceptron cannot work with all 4 of them, but we can't visualize beyond 2D. I haven't taught you what it takes to visualize 3D. So we are just going to limit ourselves to 2 features. But when we finish the code that we write, we can change something and it will work with all the features. Now, what will tell you whether the features you are using can get the job done or not depends on the exploratory data analysis that you do. You need to see the plotting with your eyes and determine whether it is linearly separable or not. So what I'm going to do here is I'm going to select only the rows that have setosa or versicolor. And I told you that setosa is 0, versicolor is 1. In NumPy, there's a way we can select based on a criteria, okay? So you create what is known as a mask. The mask is what is used for the selection. So this is just a variable name, but the concept is known as a mask, okay? So I'll say mask is equal to np.where, and I'm saying I'm interested in where my y is equal to either 0. I'm sorry, I thought I was typing 2 equal to 0, or my y is equal to 1. So I'm creating a mask. What the mask is going to do is, this mask is like, for those of you who know SQL, it's like, look into my y and tell me the indices in the array where y is either 0 or 1. I'm only interested in, we are going to work with setosa and versicolor. Remember, I told you the perceptron can separate between only 2 classes, okay? Because it's just 1 neuron. So now that I've created this mask, I will create my X again. Now this time I'll say, I'm selecting from X only the max. And unfortunately, I can't spend time to explain this indexing to you. I have all the videos on my channel, so take some time and learn NumPy properly. If you want to get anywhere in AI, you can't run away from it. You can hate it all you want. That means you don't want to be an AI practitioner. So I'm selecting the X, like all the rows in the X that matches the mask that I created in the Y. Remember that for every row in X, there's a corresponding Y. So if I mask in the Y, I can use that return to select from the X, okay? And over here, I'm interested in all the rows, but I'm only interested in column 0 and column 2. What is column 0? Column 0 is sepal length. Column 2 is petal length. We come from 0, 1, 2, and 3, even though they are 4, okay? So I have selected my X. So now my X is made up of only setoses and versicolors. Then I need to select the corresponding Y's too, okay? So I'll say Y is equal to Y, and then I'm selecting the mask, okay? So we've done the selection. Now we can check the shape of our X and Y again. So I'll say X.shape, and then I also check Y.shape. So I expect that now my X is made up of 100 rows, 2 columns. Why? Because I'm selecting only column 0 and column 2 here. And it is 100 because in the original data set, they gave you 50 setoses, 50 versicolors, and 50 virginica. But we said we are only interested in setosa and versicolor. So we are not doing anything with virginica. That is why we have 100 now. So this code here has taken away everything that is not setosa and is not versicolor. We can also do, we can print np.unique. We can check the unique values in our Y now, and we can indeed see that it is now either 0 or 1. We are not doing anything with the 2, okay? All right. So now let's separate X even further, because now X is made up of both setoses and versicolors. But we want to plot and see how setoses will be grouped compared to how versicolors will be grouped, okay? And then that will tell us whether the data set is linearly separable or not. So how do we do that in NumPy? I can say my setoses